Welcome to the Quiet Science. Tonight you have found your way somewhere unhurried. It is night, and you are ready to let the day go. The Quiet Science sits beside you, not to answer, but to remember, together. And tonight we remember something enormous made quietly small. The question of whether, out there in all that darkness, anything else is alive. There is a number that lives inside your body right now. Not a measurement, not a count, a ratio. For every atom that makes you you, the carbon in your breath, the iron in your blood, there are roughly 10,000 billion stars in the observable universe. 10,000 billion. That number is not dramatic if you say it fast. It only becomes something if you let it sit. And here is the quiet strangeness of it. Every one of those stars is a sun. Many have planets. Many of those planets have water. Some of those planets are old, older than Earth by billions of years. Life here took about 400 million years to appear once conditions allowed it. 400 million years sounds long. Against the age of the universe, it is almost nothing, a breath. So the question arrives, not urgently, but persistently, the way a sound does when you finally stop talking. Is anything out there? We do not know. That fact alone, that we genuinely do not know, is one of the most unusual facts in all of science. We are a civilization that has split the atom, mapped the human genome, and sent machines to the edge of the solar system. And still, we do not know. Tonight, that question is our companion. Not to be solved, to be understood more deeply than you have understood it before. Settle back now. Let your weight drop into whatever is beneath you. You do not need to hold anything tonight. You do not need to remember any of this. You only need to receive it. The stars are very old. We are asking an old question, and old questions, asked quietly, have a way of changing us. Not by giving us answers, but by showing us exactly how much wonder fits inside the not knowing. Before we go further, let the room settle around you. The light is low or gone. Your breathing has begun to slow without you asking it to. This is what night does. It removes the day's permissions. You are allowed to not accomplish anything right now. There is a field in science called astrobiology. It is less than 30 years old as a formal discipline, but the question it studies, whether life exists elsewhere, is as old as human thought. The ancient Greeks asked it. Epicurus, writing around 300 BCE, said the universe likely held many worlds and many forms of life. He had no telescope, he had no data, he had only logic. And logic said, if this happened here, why only here? That argument has never quite gone away. Scientists today call a version of it the mediocrity principle. It states, formally, that Earth is not special, that we should not assume we occupy a privileged position in the cosmos. This is not a pessimistic statement. It is, in a quiet way, a generous one. It says, what happened here is not a miracle reserved for us alone. It may be, probably is, something the universe does. Let that sit for a moment. Life, not as accident, life as something the universe inclines toward. We do not know that this is true, but the logic is not unreasonable. And tonight, we are going to follow the logic, slowly, gently, through the actual science of what we know and what we do not. There is no need to stay awake to receive this. In fact, the quieter you become, the more of it tends to land. That is how the best science works. Actually, it does not demand your attention. It rewards your stillness. Let us begin with the facts that feel the most ordinary and are actually anything but. The universe is approximately 13.8 billion years old. Earth is approximately 4.5 billion years old. Life on Earth appeared at least 3.7 billion years ago. Possibly earlier. That means life appeared on this planet when the universe was less than 10 billion years old, when enormous numbers of stars had not yet formed, when planets like Earth were still, in cosmic terms, relatively new. This timing matters for a reason that is not obvious at first. If life appeared here so early in Earth's history, it may mean life is not difficult to start, not rare, not the result of extraordinary coincidence, but something that happens relatively readily, given the right ingredients. Astrobiologists call the ingredients simple: liquid water, an energy source, and organic chemistry. Organic chemistry, the chemistry of carbon-based molecules, turns out to be everywhere. In 1969, a meteorite fell in Murchison, Australia. Scientists have spent decades analyzing it. Inside, they found over 90 different amino acids. Amino acids are the building blocks of proteins, the molecules that carry out virtually every function in living cells. These amino acids formed in space, without biology, without intention. They were simply chemistry doing what chemistry does when conditions allow it. The implication is slow and wide. The raw material of life is not rare. It drifts between stars. It arrives on rock. It has been doing this for billions of years, across billions of galaxies. Somewhere in the room right now, your ribcage is rising and falling. You do not have to manage it. The chemistry manages itself, just as it always has, just as it may be doing right now, in places we have never seen. There is a word astrobiologists use that I want to place here gently: extremophiles. These are living organisms on Earth that survive in conditions once considered completely hostile to life. The word sounds clinical. The reality is quietly astonishing. In 1977, scientists lowered a submersible to the ocean floor near the Galapagos Islands. They expected to find cold, dark, barren rock. Instead, they found vents in the ocean floor releasing superheated, chemically rich water. And surrounding those vents, life, abundant life, tube worms, shrimp, crabs, bacteria, entire ecosystems thriving without sunlight. Without sunlight. They had rewritten the basic assumption of what life requires. Since then, we have found extremophiles in almost incomprehensible places. Organisms called Deinococcus radiodurans survive radiation doses that would kill any other known creature. Bacteria have been found living inside solid rock 2 miles underground. Tardigrades, microscopic animals, survive exposure to the vacuum of space. Organisms called acidophiles thrive in water as acidic as battery acid. Each discovery does the same quiet thing. It moves the goalposts. It expands the envelope of conditions in which life is possible. And every time the envelope expands here on Earth, it expands in our imagination of what might be possible out there. There is a moon of Saturn called Enceladus. It is covered in ice. Beneath that ice, there is a global ocean of liquid water. Hydrothermal vents almost certainly exist on its ocean floor. We know this because the Cassini spacecraft detected plumes of water vapor erupting from its surface. And in those plumes, molecular hydrogen, the chemical signature of hydrothermal activity. The same chemistry that sustained those communities near the Galapagos. The chemistry that surprised us in 1977 may be happening right now, beneath the ice of a moon 900 million miles from here. There is no need to feel alert right now. Let that information move through you like water through stone, slow, patient. Reshaping things quietly. Enceladus is not a theory. It is a known place, with known chemistry, with conditions that life, as we now understand it, could use. That is not proof, but it is proximity. It is the universe placing a possibility closer than we expected. There is a question inside the larger question. It does not announce itself loudly. It hides behind the more dramatic version. Are aliens real? Do they look like us? Have they visited? The quieter question is this: what is the simplest form of life that could exist elsewhere? Not civilizations, not intelligence, just chemistry that copies itself, a cell, a microbe. Something no larger than the period at the end of this sentence. This version of the question changes the mathematics entirely. When people debate life elsewhere, they often picture beings, minds, technology contacts, but the history of life on this planet is mostly microbial. For the first approximately 3 billion years of life on Earth, the most complex organism that existed was a single cell, 3 billion years of just cells. Multicellular life is new here. Complex animal life is extraordinarily new. Intelligence is brand new. So when we ask if life exists elsewhere, we are almost certainly asking first, does microbial life exist elsewhere? And the honest answer is that most astrobiologists today believe it probably does. Not because we have found it, because the logic has become difficult to argue against. The organic molecules are everywhere. The conditions are widespread. The envelope of life's tolerance, as we keep learning, is enormous. And the universe has had 13.8 billion years to run the experiment. There is something calming about that framing. The universe is not waiting for life to happen. It has been running experiments constantly in every direction for longer than the human mind can genuinely hold. You're breathing right now. The molecules entering your lungs, each one forged inside a star that died before our sun was born. You are not separate from this story. You are the part of it that became aware enough to ask the question. Let that be enough for now. Let the question breathe. There is more to come. But the night is long and there is nowhere to be. The night holds the question for you now. You do not have to carry it. It rests here, between the science and the silence, waiting patiently. There is an equation. It was written in 1961 by an astronomer named Frank Drake. He was preparing for a scientific conference, the first serious academic gathering ever held on the question of extraterrestrial intelligence. He wrote the equation on a blackboard, not as a solution, but as an agenda, a way of organizing what we would need to know. The Drake equation, as it became known, estimates the number of communicating civilizations that might exist in our galaxy right now. It multiplies together a series of values: the rate of star formation, the fraction of stars with planets, the fraction of those planets that could support life, the fraction where life actually appears, the fraction where life becomes intelligent, the fraction that develops communication technology, and finally, the one that changes everything, the average length of time such a civilization remains detectable. Each value, when Drake first wrote them, was almost entirely unknown. Now, 60 years later, some of them are not. We know the rate of star formation in the Milky Way quite well. Approximately 3 new stars per year. We know that most stars have planets. The Kepler Space Telescope, launched in 2009, confirmed this. It found thousands of exoplanets in just a small patch of sky. Extrapolated across the galaxy, the number of planets is staggering. We now estimate there are roughly 1 trillion planets in the Milky Way alone. 1 trillion in one galaxy, among 2 trillion galaxies. The early terms of the Drake equation, once mysteries, have become almost reassuring in their abundance. Stars are common. Planets are common. The raw ingredients of chemistry are common. So the answer should be obvious. And yet, it is not. Because the later terms, how often life appears, how often it becomes intelligent, how long it survives, those remain genuinely unknown. And they are the ones that matter most. A small change in any of them can shift the estimated number of civilizations from billions to 1. 1. That possibility that we might be alone, not because the universe is barren, but because intelligent life is extraordinarily rare, sits quietly at the center of this question. Not frightening, just honest. Let your eyes close a little further if they have not already. The equation will wait. The universe will wait. It has been waiting for quite some time. Here is something worth holding gently. In 1950, the physicist Enrico Fermi was having lunch with colleagues. They had been discussing a recent news story about UFO sightings. The conversation moved, as it tends to, toward the broader question. If intelligent life is common in the universe, if there are civilizations far older and more advanced than ours, where is everybody? That question became known as Fermi's paradox. It has never been satisfactorily answered. The logic is simple. The Milky Way is approximately 100,000 light-years across, but it is also approximately 13 billion years old. A civilization only slightly more advanced than ours, with perhaps a few thousand years more development, could theoretically spread across the entire galaxy in 10 to 50 million years. Using self-replicating probes, slower than light travel, patient expansion, 10 to 50 million years sounds enormous. Against a galaxy 13 billion years old, it is less than 0.5% of the total time available. There have been billions of years during which a civilization could have emerged, expanded, and left traces throughout the galaxy. And yet we observe nothing. No signals, no megastructures, no unambiguous evidence of anyone. The silence is the paradox, not the absence of life. The silence. And that silence, strangely, is one of the most interesting data points we have. There are more proposed solutions to Fermi's paradox than almost any other question in science. Dozens of serious hypotheses. Some are unsettling. Some are oddly beautiful. Tonight we will move through several of them, the way you might move through rooms in a house you have never visited, without rushing, without needing to choose a favorite. Just rooms, each one with its own quality of light. The first room is called the Rare Earth Hypothesis. It was formally described by paleontologist Peter Ward and astronomer Joe Kirschvink, building on earlier work. It proposes that the conditions that allowed complex life to develop on Earth are not common at all. That simple microbial life may be widespread, but complex life, animals, intelligence, civilization, requires a staggering combination of circumstances. Consider what Earth has: a large moon. Our moon stabilizes Earth's axial tilt, the angle at which our planet leans as it orbits the sun. Without that stabilization, the tilt would vary chaotically over millions of years. Seasons would become something far more violent and unpredictable. The climate would oscillate in ways that might prevent complex ecosystems from establishing themselves. We also have Jupiter. The largest planet in our solar system sits far enough out that its enormous gravity acts as a kind of shield. It captures or deflects a significant number of asteroids and comets that might otherwise strike Earth far more frequently. We orbit in the habitable zone, the band of distance from our star where liquid water can exist on a surface. Not too hot, not too cold. The range is narrow. We have a magnetic field generated by our liquid iron core that deflects the solar wind and protects our atmosphere. Without it, our air would slowly be stripped away, as likely happened to Mars. Each of these factors, alone, might not be decisive. Together, they paint a picture of a planet that is not typical. And if the conditions for complex life are rare, not impossible, but genuinely rare, then the galaxy may be full of microbial worlds and nearly empty of anything that thinks. The room has a particular stillness to it, not lonely, more like the feeling of understanding why something precious is precious. Your body has been running its chemistry without interruption for every moment of your life. All of these conditions, the tilt, the shield, the magnetic field, the zone, they have been quietly in place for every breath you have ever taken. You did not know. You did not need to. The universe arranged it. And here you are. There is another room. This one was described by paleontologist and evolutionary biologist Stephen Jay Gould, and later developed by others. It involves a thought experiment. Imagine rewinding the tape of life on Earth 4 billion years, back to the first self-replicating molecules, then pressing play again. Does the same thing happen? Does evolution, given another 4 billion years, arrive again at something like us? Intelligent, technological, language-using? Gould believed the answer was almost certainly no. His reasoning: evolution does not aim at anything. It is not a process with a destination. It responds to local conditions, moment by moment, through random mutation and selection. The emergence of human-level intelligence required an extraordinary chain of specific events. The extinction of the non-avian dinosaurs 66 million years ago. The consequent opening of ecological niches for mammals. The particular climate changes that shaped the African savanna. The specific pressures that drove the development of bipedalism, freeing hands. The further pressures that expanded the prefrontal cortex. Change any link, alter any event, the chain breaks. Something else arrives, not nothing. Something else, maybe wonderful in its own way, maybe unimaginably different. This is not discouraging. It is clarifying. It suggests that intelligence, specifically our kind of intelligence, language using and tool making and star wondering, may not be the inevitable product of evolution. It may be one path among countless. And if that is true, then the galaxy may hold life in forms so different from us that we would not recognize the question in their presence, or we would not recognize them. A biosphere that communicates through chemistry, not sound. Organisms that experience time at a radically different rate. Something that processes its world through senses we do not possess and cannot imagine. We keep searching for signals that look like ours. Radio waves, mathematical patterns, the things we would send. But the range of what life could be. Here, tonight, suggested by our own biosphere alone, is already far stranger than the signals we are listening for. Let that breathe for a moment. The ceiling or the darkness above you, imagine it is not a ceiling. Imagine it opens into everything else. You do not have to hold the scale of it. It holds itself. The question only requires that you remain present to its edges. There is a concept with a name that sounds dramatic, but is actually one of the most quietly considered ideas in all of astrobiology: the Great Filter. It was proposed by economist Robin Hanson in 1998. It asks, if the universe is old and vast and seemingly favorable to life, why do we see no evidence of advanced civilizations? The answer, Hanson suggested, may be that there is some step, some transition that is extraordinarily difficult to pass through a filter. Something that prevents most or nearly all life from advancing to the point of becoming detectable across interstellar distances. The crucial question, the one that keeps astrobiologists up at night, or perhaps helps them sleep, depending on their temperament, is this: has the filter already been passed by us, or does it lie ahead? If the filter is behind us, if the difficult step was the origin of life itself, or the development of the nucleus in cells, or the emergence of multicellular organisms, then we are fortunate, extraordinarily fortunate. We have already made it through the hard part. But if the filter lies ahead, if the difficult step is something that technological civilizations reach and rarely survive, if there is some threshold, perhaps the development of weapons capable of planetary destruction, or the misalignment of powerful artificial intelligence or ecological collapse, that nearly all civilizations reach and fail to pass, then the silence of the universe carries a different quality. Not evidence that we are alone, because life is rare. Evidence that we are young, and that what comes next is the difficult part. This is not a frightening idea to hold at night. Not really. It is a very honest one. And honesty, even at scale, has a way of settling the nervous system rather than disturbing it. You are here. This night is here. Whatever comes next in the long story of this civilization, it has not come yet. Right now, you are breathing. The question is alive in you. That, by itself, is something. The night has deepened around you now. The science has been arriving quietly, the way starlight does, not all at once. Accumulated padded. There is a signal. It arrived on August 15, 1977, a radio telescope in Ohio, part of a SETI project. The search for extraterrestrial intelligence was scanning the sky. The data was printed on paper. As was common then, a researcher named Jerry Eman reviewed the printout days later. He found something, a narrowband radio signal lasting 72 seconds. Originating from the direction of the constellation Sagittarius, at exactly the frequency that hydrogen, the most common element in the universe, naturally emits radiation. A frequency that scientists had long theorized would be a logical choice for any civilization attempting to communicate across interstellar distances. The signal was so striking, so far above the expected noise level, that Eamon circled it on the printout and wrote one word in the margin: wow. It became known as the WOW signal, and it has never been explained. No natural astronomical source has been identified that could produce it. It has never been detected again, despite decades of searching in the same region of sky. It remains, technically, an open case. This is a real thing, not mythology, not speculation. A documented observation made by a serious scientific instrument for which no satisfactory natural explanation exists. We do not know what it was. The not knowing here is different from other not knowings. Most unanswered questions in science feel like gaps waiting to be filled. This one feels more like a door that was opened briefly and then simply closed. There is no drama required in that. Only a kind of quiet attention. Something arrived, or something echoed, or the universe produced something we do not yet have a category for. And then silence, the same silence that surrounds us now, enormous and patient and not telling us what it means. Let us move into a different kind of territory now, not outward but inward, not space but time. One of the most quietly unsettling realizations in astrobiology involves not the distance between civilizations, but the time between them. The Milky Way is 13 billion years old. Civilizations, if they exist, have not all evolved at the same moment. They are distributed across billions of years of galactic history. A civilization that emerged a billion years before us, and there are stars old enough to have hosted such civilizations, would be separated from us not just by distance but by time. 1 billion years. On this planet, 1 billion years ago, the most complex living things were simple, multicellular organisms. Nothing with a nervous system, nothing with a sense. What does a civilization do with 1 billion years of development? We have had approximately 10,000 years of what we call civilization. We have had approximately 300 years of modern science, approximately 60 years of spaceflight. Extrapolating forward 1 billion years from where we are now is not something the human brain can do meaningfully. It exceeds our imagination the way the ocean exceeds a teacup. This is the point where science quietly hands off to something more like philosophy or wonder. A civilization 1 billion years old would not necessarily be recognizable as a civilization. Its technology might be indistinguishable from the structure of nature itself. Its communications might not look like signals. They might look like physics. This idea has a name: Arthur C. Clarke expressed it as his third law, nay, sufficiently advanced technology is indistinguishable from magic. But the deeper implication, the one that lands quietly at this hour, is something else. We are searching for civilizations that look like us, that broadcast like us, that build like us. We may be searching, essentially, for ourselves. And the universe may be full of things so far beyond that frame that our instruments pass right through them, detecting nothing, the way a net designed for whales cannot catch water. There is a star. It sits approximately 1 in 400 light-years from here. Its name is KIC 8462852. Astronomers have taken to calling it Tabby's star, after Tabeth Boyajian, the astronomer who led the analysis of its unusual behavior. Between 2011 and 2013, the Kepler telescope observed this star dimming in patterns unlike anything seen before. Not the small, regular dips caused by a planet passing in front of a star. These were irregular, dramatic. Sometimes the star's light dropped by 22%. Sometimes the dimming lasted days, sometimes weeks. The pattern repeated with no discernible regularity. No natural explanation has been fully satisfying. Swarms of comets were proposed and found insufficient. Dust clouds have been modeled and remain contested. One hypothesis, taken seriously, if not conclusively, by a small number of researchers, invoked the concept of a Dyson sphere. A Dyson sphere is a theoretical megastructure. The physicist Freeman Dyson proposed in 1960 that a sufficiently advanced civilization might build a structure. Not necessarily a solid shell, but perhaps a swarm of energy-collecting satellites, surrounding their star entirely, harvesting all of its output. A civilization advanced enough to build such a structure would be, by any measure, incomprehensibly more developed than we are. And such a structure, if it existed, would cause exactly the kind of irregular, dramatic dimming we observed at Tabby's star. The scientific consensus currently leans toward natural explanations: dust, debris, something we understand imperfectly. But the fact that the hypothesis was considered at all, soberly, in peer-reviewed papers by working astronomers says something. We have reached a moment in our science where the existence of megastructures built by other civilizations is a legitimate scientific hypothesis. Not science fiction, a hypothesis. One that can be tested, in principle, by observation. This is a new kind of moment, not many generations ago. Asking whether other civilizations existed was a philosophical question, a matter of belief. Now it is an empirical one. We have instruments, we have methods. We are, slowly, actually looking. The ceiling above you, or the darkness, holds that thought. We are looking. After all this time, we are finally, formally looking. Here is where the story becomes personal, not personally meaningful in a vague way. Literally personal, connected to your body, specifically. Every atom of carbon in you was forged in the nuclear furnace of a star, not our sun. Our sun is too small and too young for that. Older stars, larger stars, stars that lived and died before our solar system formed. When those stars exhausted their fuel, they exploded, supernovae. Events so energetic that for a brief period, a single dying star outshines an entire galaxy of hundreds of billions of stars. In that explosion, the carbon and nitrogen and oxygen and iron, the elements that make up your body, were scattered across space. They drifted for millions of years through the interstellar medium until gravity gathered them into new clouds, new disks, new planets. Our planet, eventually you. This is not metaphor. This is documented nuclear astrophysics. The carbon in your cells carries the history of stellar death. Now hold that alongside the question of life elsewhere. If the same process happened elsewhere, and it did, countless times, in countless star systems, then the same raw material was scattered, gathered, and potentially assembled into life in other places. You are, in a precise and documented sense, made of the same stuff as any life that may exist anywhere in the universe. Not similar stuff, the same process, the same stellar origin, the same nuclear reactions, producing the same elements. If there is a microbe beneath the ice of Enceladus, and if we ever find it, we will be meeting something made by the same ancient fires that made us. Not family in the way we use the word. Something quieter and larger than family. Something more like the same sentence written twice in different handwriting, in different corners of a library so vast that neither copy knows the other exists. Your breathing is slower now. Your body knows how to do this. It has known since before you were born. This is what rest does. It returns you to the processes underneath the thinking. The same processes the universe has been running for 13.8 billion years in you, right now. There is one more consideration before the night deepens further. It is the one that scientists speak about most carefully, with the most measured language, because it carries the most weight. The possibility of life that is not microbial, not simple, but intelligent. And the question of what it would mean, not scientifically, but for us as a species, to confirm it. In 2015, a group of scientists and technologists signed an open letter calling for a moratorium on a practice called active MET. MET stands for Messaging Extraterrestrial Intelligence, the sending of deliberate, powerful signals into space intended to be received. The concern was straightforward. We do not know what is out there. We do not know the intentions or nature of any civilization that might receive a signal. And contact, once initiated, cannot be uninitiated. The letter was controversial. Others argued that we have already been broadcasting radio and television signals for over a century, that any civilization capable of detecting them could already find us if they wished, that the moratorium was a barn door locked after the horse had left. Both sides were taking the question seriously. That is the point, not the conclusion, the seriousness. The fact that serious people argue in measured tones about the protocols for contacting extraterrestrial intelligence, as if it were an eventuality requiring policy, not merely a fantasy requiring dismissal, tells you something about where this question now lives in science. It lives in the realm of the real, the possible, of the worth preparing for. And tonight, lying here in the dark, you are part of the species that is asking. You are the part of the universe that wonders about itself, the part that looks outward and feels the looking. There were billions of years before anything could do that. There may be, we do not know, beings elsewhere doing the same, lying in their equivalent of night, asking their equivalent of the question, wondering quietly whether they are alone. The question has settled into you now, not as something to solve, as something to carry lightly, the way the body carries warmth. There is a spacecraft, 2 of them, actually, launched in 1977, the same year the WOW signal arrived, Voyager 1 and Voyager 2. They were sent to study the outer planets, Jupiter, Saturn, Uranus, Neptune. They did that, and did it extraordinarily well. But they kept going. Voyager 1 is now the farthest human-made object from Earth. As of today, it sits approximately 24 billion kilometers away, still transmitting, still in contact. Its signal, traveling at the speed of light, takes over 22 hours to reach us. In 2012, it crossed into interstellar space, beyond the heliosphere, the bubble of solar wind that our sun inflates around the solar system, into the space between stars, a human-made object in the space between stars. That fact has not fully entered our cultural imagination yet. it tends to slide past us. But hold it for a moment. Something built by human hands, designed by human minds, launched by human intention, is now moving through the same medium that separates us from every other star, from every other possible world, from every other possible answer to the question we are sitting with tonight. On board both Voyager spacecraft, there is a golden record, literally golden, a gold-plated copper disc. It contains sounds and images selected to represent life and culture on Earth. Greetings in 55 languages, music from dozens of traditions, the sound of wind, rain, surf, the sound of a mother's first words to a newborn child, mathematical and scientific information, a map of sorts showing how to find us. Carl Sagan, who chaired the committee that assembled its contents, described it as a message in a bottle cast into the cosmic ocean. The record will outlast every building currently standing on Earth. It will outlast, almost certainly, every written language. In the absence of collision, it will travel through interstellar space for billions of years. No civilization is likely to find it. The distances involved make that nearly impossible by chance. It was never primarily about being found. It was about the act of sending, about the decision to introduce ourselves to a universe that may or may not be listening. There is something in that gesture that belongs here, at this hour, not the hope of reply, the act of reaching. You have done this, in smaller ways, your entire life. Extended yourself towards something without knowing what would receive you. And sometimes the reaching itself was the thing that mattered. In 1990, as Voyager 1 was leaving the solar system, Carl Sagan made an unusual request. He asked NASA to turn the spacecraft's camera around, to point it back at Earth. They did. The resulting photograph shows our planet as a tiny point of light, pale blue, suspended in a beam of scattered sunlight, barely distinguishable from the surrounding darkness. Sagan called it the pale blue dot. He wrote about it, and the passage became one of the most widely shared pieces of scientific writing in the modern era. His central observation was this: every human being who ever lived, every act of kindness or cruelty, every war and every peace, every birth and every death, all of it occurred on that dot, on that mote of dust suspended in a sunbeam. The image did not make him feel small. It made him feel the weight of what we are responsible for. This single, fragile world, this one confirmed address in the cosmic directory. The only place, as far as we can currently prove, where the universe has become aware of itself. That awareness, the capacity to look outward, to question, to wonder, to grieve, and to love, may be common, or it may be extraordinarily rare. We do not know. But either answer carries the same instruction. If awareness is common, we are part of something ancient and widespread. One voice in a conversation that has been ongoing for billions of years. Our care for this world is our contribution to that conversation. If awareness is rare, if we are among the first or the few, then what happens here matters in a way that extends beyond us. Our care for this world may be the only care this part of the cosmos currently has. Both answers ask the same thing of us. That is a thought worth carrying into sleep, not as a burden, as a quiet orientation, a soft compass bearing. There is a quality to this question that most scientific questions do not have. Most questions, when answered, become smaller. The mystery resolves. The phenomenon is explained. The territory is mapped. This question does something different. Every piece of evidence we gather, every exoplanet discovered, every extremophile found, every amino acid in a meteorite, every unexplained signal, makes the question larger rather than smaller, not more confusing. More spacious, more room inside it for what we do not know. This is a particular kind of scientific experience. Physicists encounter it at the quantum level, where the more precisely you measure, the more uncertainty appears in adjacent measurements. Cosmologists encounter it at the largest scales, where the more accurately we map the universe, the more clearly we see how much of it, dark matter, dark energy, remains beyond our current understanding. The question of life elsewhere belongs to this family. The honest answer, at every stage of investigation, seems to be, we know more than we did, and the space of what we do not know has grown accordingly. This is not failure. It is what genuine inquiry feels like. The night is doing something similar right now. The quieter you become, the more you notice. Not more noise, more texture in the silence. Your body is doing the same. As you settle deeper into rest, processes that were running beneath your awareness begin to surface, not as thoughts, as sensations, the weight of your limbs, the rhythm of your breathing, the particular quality of this specific night. Science and sleep share this. Both reward the willingness to stop asserting and simply receive. There is a concept called the cosmic perspective. It is not a technique or a philosophy. It is simply what happens when you allow the actual scale of things to arrive without filtering it through the usual reassurances. The observable universe contains approximately 2 trillion galaxies. Each galaxy contains, on average, hundreds of billions of stars. The number of planets is effectively uncountable, and we know, with confidence, that the chemistry of life is not unusual. It appears spontaneously under a wide range of conditions. It has been running here for nearly 4 billion years. Against that backdrop, the idea that life exists only here, only on this single planet, orbiting this single unremarkable star, in the outer arm of one average galaxy, requires, if you follow the logic carefully, a very particular kind of specialness. Not impossible, the rare Earth argument is serious, but a particular kind of specialness. The alternative, that life is, at some level, a general feature of a universe with these physical constants and this chemistry, requires no such specialness. It requires only that what happened here happened elsewhere too. Most scientists, if pressed privately, will tell you they believe we are not alone in the simplest sense, that somewhere, in some form, life exists elsewhere. Most will also tell you they are genuinely uncertain whether we will ever confirm it. The distances are extraordinary. The timescales are extraordinary. The forms life might take could be so different from anything we have imagined that finding it might not look like finding it. This is a strange position to occupy. Believing something is probably true, suspecting it may be unverifiable, continuing the search anyway. It is a very human position. We have been in it before. The first people who looked at the stars and felt certain, with no instruments, no mathematics, no evidence, that something was out there among them. They were not wrong to feel it. They were just very early. You are not early anymore. You are here at this particular moment when we have the instruments. When we have found the amino acids in the meteorite and the plumes from Enceladus and the thousands of exoplanets, when the question has moved from philosophy into science. And still, we do not know. There is enormous dignity in that position. To hold a question this large, this honestly, for this long, without requiring it to resolve before you can rest. Your shoulders, if you notice them now, can drop a little. The jaw, if it has been holding anything, can release. The question does not need you to solve it tonight. It has been open for as long as human beings have looked upward. It will remain open in some form for a long time yet, but something has changed tonight. You have moved through the actual science of it, not the dramatic version, not the version that needs answers to be satisfying, the real version, the one that sits comfortably with uncertainty because it has looked at the evidence carefully and found that uncertainty is the honest response. You have moved through the organic molecules drifting between stars, the extremophiles rewriting our sense of where life can live, the moons with liquid oceans beneath their ice, the equation on a blackboard that turned out to be an agenda for a century of science, the signal that arrived in 1977 and has never been explained. The golden record moving through interstellar space right now, carrying the sound of a mother's voice to wherever the universe takes it. You carry all of that now, not as information to remember, as a slightly different sense of what this night is part of. The darkness outside is not empty. It is full of distances, full of time, full of chemistry that the universe has been running patiently and without announcement. And you are the part of that chemistry that became curious. That asked the question, that lay down tonight and let the asking be enough. The night is very quiet now. What you know has settled. What remains unknown has found its place too, not as absence, but as space. There's a word that appears in the scientific literature on this subject. It appears rarely carefully, as if the researchers who use it are aware they are stepping slightly beyond the usual boundaries of their field. The word is loneliness, not as a diagnosis, as a data point. Several researchers studying the psychological dimensions of the Fermi paradox have noted something unusual about the human response to the silence of the universe. When people genuinely absorb the scale of the cosmos, not intellectually, but viscerally, the way you absorb it on a clear night far from city lights, they do not typically feel small, not first. They feel alone. And then, almost immediately, they feel something harder to name, a kind of reaching, an orientation toward the darkness that is not fear, but something more like recognition, as if the body already knew the question before the mind formed it. This response has been documented in astronauts. Many who have seen Earth from orbit describe a shift that is difficult to articulate. Edgar Mitchell, who walked on the moon in 1971, described looking out at the stars and feeling with sudden certainty that the universe was in some way conscious. Not in a religious sense, he was careful to say, in a structural sense, as if awareness were woven into the fabric of things. He described it as an instant global consciousness, an overwhelming sense of connection, not to God, not to any doctrine, but to the fact of existence itself. This experience has been reported by enough astronauts that researchers have given it a name, the overview effect. It is not mysticism. It appears to be what happens to the human nervous system when the actual scale of reality is directly perceived rather than abstractly understood. Something in us responds, something orients. Whatever that response is, wherever it comes from, it has been with our species for as long as we have records. The first cave paintings show hands reaching outward. The first written myths reach upward. The first philosophers asked whether the stars were inhabited. We have always been oriented this way, toward the question, toward the darkness, toward whatever might be looking back. Here is something science knows and rarely says plainly. Consciousness, the fact that there is something it is like to be you, is not explained. Not partially explained. Not mostly explained with some details still unclear. Not explained. We know which brain regions are active during various states of awareness. We know that disrupting certain neural processes disrupts consciousness. We know a great deal about the correlates of experience. But the hard problem, why physical processes give rise to subjective experience at all, why there is something it feels like to see blue or hear music or lie in the dark wondering about the universe. That problem remains genuinely open. The philosopher David Chalmers named it the hard problem of consciousness in 1995. It has not been solved in the 30 years since. Most researchers who study it seriously believe it may be the deepest question in science. This is relevant to the question of life elsewhere in a way that is easy to miss. When we ask whether we are alone, we are usually asking about biology, about chemistry, about the conditions for cells. But underneath that question is a quieter one. Is awareness, the quality of experience, the fact of an inside, something that emerges only from particular biological arrangements? Or is it something more fundamental? Something the universe produces more readily than we assume? Some serious physicists and philosophers, not the fringe, but careful thinkers like Roger Penrose and David Chalmers himself, have entertained the possibility that consciousness is not produced by complexity, but is in some form a basic feature of reality. Like mass, like charge, like time. This position is called panpsychism. It is not mainstream. It is also not dismissed. If it carries any truth, if awareness is not an accident of biology, but a feature of the physical world, then the question of whether we are alone takes on a different texture entirely. Not, is there other life out there? But, is the universe itself, in some distributed and unimaginable way, already aware? That question has no answer tonight. It may have no answer for a very long time. But it is a real question held by real scientists in real journals. And you are the part of whatever this is that can lie quietly in the dark and feel the weight of it without needing to resolve it. That capacity, the tolerance for open questions, may be one of the most sophisticated things a mind can do. Let the body receive some attention now, not effort, just awareness moving gently through the back of the head, where it rests against the pillow or the surface beneath you. That contact, the shoulders, which have been holding the sky all day without being asked. They can release that now. The chest, rising and falling, doing what it has done every moment of your life, including every moment you were unaware of it. The hands, whatever position they have found. They do not need to hold anything right now. The question of the universe is not something your hands can hold anyway. It is something your whole being holds, quietly, simply by being the kind of thing that asks. We have been moving through a long question tonight, but there is a layer beneath it that we have not yet named directly. The question of whether we are alone is, underneath, a question about meaning, not meaning in an abstract philosophical sense. Meaning in the most immediate sense. Does what happens here matter? If we are one of billions of civilizations scattered across the galaxy, then our history, our wars and discoveries and arts and extinctions, is one thread in an incomprehensibly large tapestry, significant but not singular. If we are alone, if this planet is the only place where the universe has become aware of itself, then what happens here carries a weight that is almost impossible to absorb. Every act of kindness, every piece of music, every child learning to speak, every scientist staying late to look more carefully at an anomalous signal, the only such events in the observable universe. Both possibilities ask something of us. The first asks us to be humble. The second asks us to be careful. Neither allows us to be indifferent. The astronomer Vera Rubin, whose observations provided some of the strongest early evidence for dark matter, once said that in her experience, the universe was far more interesting than any of our theories about it. She was not speaking about extraterrestrial life specifically. She was speaking about the practice of genuine attention, of allowing what is actually there to exceed what you expected. That practice, the practice of genuine attention, of allowing reality to be larger than your current model of it, is quietly, What this entire question requires, not certainty, not resolution. Attention, the kind you are practicing right now, lying here, receiving the night, letting the question be as large as it actually is. Something shifts, very late in the night. The thinking mind begins to soften its grip, not because you asked it to, because sleep is a biological process that does not require permission. The brain begins to move towards sleep through a sequence of stages that neuroscientists have mapped carefully. Alpha waves give way to theta waves. The body temperature drops slightly. The muscles release tension they have been holding since morning. And the mind, the part of you that has been following this story, weighing the evidence, feeling the scale of the universe, that mind begins to loosen its hold on the content. The ideas stop being ideas. They become something more like weather, atmosphere, a quality of the night rather than a list of facts. This is not forgetting. This is integration. Sleep researcher Matthew Walker has described how the sleeping brain does not simply store the day's experiences. It connects them. It finds relationships between new information and existing knowledge. It builds bridges that the waking mind, too focused on the immediate, cannot build. What you have received tonight. The amino acids in the meteorite, the ocean beneath Enceladus, the golden record, moving through the dark, the overview effect in returning astronauts, the hard problem of consciousness, the pale blue dot. None of it needs to be cataloged. The sleeping brain will do something with it. Something you will not be awake to observe. Something that may surface days from now as a slightly different sense of what the night sky is. Or it may surface as nothing visible at all. Just a quiet shift in the weight of the question. A millimeter of additional spaciousness around the not knowing. That is enough. That is, in fact, exactly what this kind of learning is for, not to produce answers. To expand the capacity to hold the question, the stars outside, wherever you are, whatever the weather, are still there. They do not require clear skies to exist. They burn whether you can see them or not. They have been burning through every night of your life, through every night of every human life, through the long silence before our species arrived to notice them. And they will burn through the night ahead, through your sleep, through whatever dreaming finds you, ancient, indifferent to whether you are watching, but somehow, in a way science can describe but not fully explain, changed by the fact that something on this small, warm planet learned to look up and ask. The night has almost done its work. The science has traveled as far as it needs to. What remains now is simpler. Closer, the distance between you and sleep is very small. There is one image worth carrying into the dark, not a fact, not an argument. An image, somewhere, distance unmeasured, direction unknown. There may be something alive, not necessarily watching, not necessarily wondering, simply alive. Running its chemistry, doing what living things do, persisting through time in the way that life persists. Without knowing it is not alone. And here, on this side of the distance, you are doing the same, running your chemistry, persisting through this particular night, without knowing, with any certainty, whether anything on the other side exists. Two unknowings facing each other across the dark. That image does not require the other side to be real. It is enough that it is possible. That the universe is the kind of place where it is possible. Possibility, at this scale, is not nothing. It is a form of company. The not knowing itself becomes a kind of presence. The question becomes a kind of warmth. You have been holding it all night. It has, in its way, been holding you. The breath is slower now. Each exhale a little longer than the one before. The body has been moving toward this all evening. This is what it was always heading for. Ret is not an absence of the day. It is the body returning to its oldest knowledge, the knowledge that existed before language, before question. Before the first human mind looked up and felt the scale of the sky. Your cells do not wonder about the universe. They simply do what they do, divide and repair and signal and rest, with a patience and precision that no conscious effort could improve. You can trust that now. The body knows, it has always known. The wondering mind can set its work down. Not permanently. Just for tonight, just for these hours, the questions will be there in the morning. The stars will be there. The silence will be there. Enceladus will still be turning in its slow orbit around Saturn. The Voyager will still be moving outward 1 kilometer per second into the space between stars. None of it requires your attention right now. There is a particular quality to late night that has no name in science. The instruments do not measure it, but you know it. The way the darkness at this hour feels different from the darkness of early evening, fuller, somehow, more settled, as if the night has found its depth and is now simply resting in it. You are part of that now, not observing the night. Inside it, the question of whether we are alone, that vast, patient, unresolved question, belongs to the daytime mind, to the upright, searching, instrument-holding part of our species. The part of you that is here now, at this hour, needs no question. It is already part of the answer. You are the universe being aware of itself. That is not poetry. That is the most accurate description available. Hydrogen, gathered by gravity, warmed by fusion, scattered by explosion, reassembled across billions of years into something that can lie quietly in the dark and feel the weight of existence. That is you, right now, in this specific moment of this specific night. Not separate from the cosmos, asking the question. The cosmos, asking the jaw, can soften completely now. The space behind the eyes, the throat, the chest. Everything the day asked you to hold. You can release it into the dark. The dark is not empty. You know that now. It is full of distance and time and chemistry and possibility. It can hold what you release into it. The golden record is out there somewhere, carrying a mother's voice, moving through the silence between starsat, a speed that will take it tens of thousands of years to reach even the nearest neighboring solar system. That voice is still traveling, right now, while you sleep. You do not need to accompany it. Your work tonight was simply to know it exists, to hold the question it represents, to be, for these hours, the part of this pale blue dot that stayed awake. Long and Odo, remember what we are part of. Salt Leaf is arriving now, not as an event, as a return. The brain is already moving through its quieter rhythms, the theta waves, the slow loosening of the day's constructions, somewhere in the galaxy. In the direction of Sagittarius, perhaps, where the wow signal came from. The stars are doing what they do, burning, scattering their light across distances that make the word distance seem inadequate. And here, in this small warm room, on this small warm planet, at the edge of one ordinary spiral arm of one ordinary galaxy, you are breathing slowly. Each breath a transaction between your body and an atmosphere built over billions of years by living things that came before you. Each exhale returning something to the air that the next breath of the next living thing will use. You are not separate from the story. You are a current moment in it. The universe has been running for 13.8 billion years without a single pause. It will continue without requiring your attention tonight. You can sleep now. The question remains open, as it should. The silence remains full, as it always was. And somewhere, perhaps, in the dark between the stars, something else is breathing too.